everyone, welcome to my talk. My name is Shreya Rajpal, and today I'm going to be talking about how to build guardrails for your AI applications and like generally why do you need them overall. So a little bit about me. I am the CEO and co-founder at Guardrails AI. In the past, you heard a little bit about this, but TLDR, I've spent about a decade or so working in machine learning. I did a lot of research and published a few papers in classical AI, computer vision, decision-making under uncertainty. For a few years, I worked on ML for self-driving cars and how do you bring self-driving cars to production. After that, I was the first hire and the ML infra lead at an MLOps company in San Francisco. And since the beginning of the year, I've started Guardrails AI, both the open source framework as well as the company. Awesome. With that out of the way, a lot of us are here because we're seeing this Cambrian explosion of applications in AI. There's generally a lot of enthusiasm about what we can really build, be it like medical tools, sales. I've added this one tweet here where there's a lot of enthusiasm and optimism about software engineering as a whole being like replaced with generative AI. There's this little chart here about Google Trends, interest in AI over time, and you can kind of like clearly see where ChatGPT was released and the kind of spike that led to, which is very interesting for me, as I've been kind of like working in this field. But the reality of generative AI applications is a little bit different. So even though ChatGPT has been the fastest application ever to reach 100 million users, especially compared to all of these other consumer AI consumer applications, if you look at the retention or the or how many people kind of keep coming back or daily active users, etc., of generative AI first applications, a lot of that tends to be significantly lower compared to their software counterparts. So I've included this graphic here from this fantastic article by Sequoia Capital that I recommend everybody go and check out. But both the 1 month retention as well as the daily active users are significantly lower for any other non-AI based application. So why is this the case? A very, very common symptom as you're working with generative AI and these really large, reasoning models, a very common symptom is that my application worked while I was prototyping, but the moment that I shared it or sent it over to somebody to, test out in production, it failed or it had these weird errors or it basically did not behave how I wanted it to. And the root cause for this symptom is that ML is fundamentally non-deterministic. And so it works very differently compared to software. So if you think about how software applications have typically worked in the past, there's some API. And then every single time you hit that API, for the same request, you're going to end up getting the same output within some margin, right? So this is not to do with uptime or availability, but it's basically to do with correctness. As an example, if you hit a database API, with some query, as long as the underlying data of that system doesn't change, you're going to end up seeing the same response or the same output from that query all the time. And it's this fundamental property that has allowed us to, build all of these really complex software architectures, with the high level of confidence and reliability that we're used to. So don't index on the architecture right now, but typically there's this, really complex interwoven web of, different APIs and services that lead into each other. If you think about now how machine learning works, and specifically how generative AI APIs work, how we're building applications is treating them as an API, right? But even with any ChatGPT endpoint or any application, you send the exact same query to it multiple times over, you're going to see very different responses. And this is the problem. This essentially means that all of the complex applications that we're building on top of generative AI APIs end up working differently, right? We fundamentally need a new paradigm to get that same level of reliability as we've all come to expect from traditional software or more deterministic software. If I were to kind of like encapsulate, like summarize this problem into one statement, it would be that getting correct outputs always is hard. And some common issues that you end up seeing are hallucinations, where the LLM or large language model makes up responses just because it's a next token prediction engine. There's falsehoods where it contradicts the data or the prompt that you typically send it. If you are building these complex applications, you typically need structure. You need like JSON payloads so that you can make those queries sequentially. But it's really hard to get LLMs to generate like a structured data output. And then you're also susceptible to vulnerabilities such as like prompt injection. To exacerbate this, we're in this situation which is pretty novel, where the only tool available to you if you're a developer is the prompt, right? So if you wanted to like work with any of these issues, all you typically do is like write a prompt that says that really, really bad things will happen if you don't, maybe give me a JSON structured output, right? I actually know somebody who builds, complex APIs on top of these LLMs, and her prompts actually, and this is an application that is in production, used by customers, the prompt actually contains someone will die if your output is not structured in this manner, which is honestly pretty funny. So all of this, ends up in the situation where the use of LLMs is limited anywhere where you have a correctness critical applications, right? Like for example, ChatGPT, you ask it a few questions, it's wrong, you kind of like, give it feedback and then move on. Same with GitHub Copilot. But if you aren't in an application where you have that same level of, flexibility, how do you add correctness guarantees when you're working with LLMs? So I've added this tweet here by Alex Gravely, the creator of GitHub Copilot, that talks about a very, very simple idea, which is that if you add a constraint checker to check for valid generation for LLMs, and then on violation, any rule that is violated, you add it back to the prompt, right? It's a very simple idea. Interestingly, the tweet by Alex came, I think, a couple of weeks ago, but Guardrails AI, the framework that I'm here to talk about as the open source package, that was released in earlier this March and kind of takes this very, very simple idea and uses it to bridge the gap between the non-determinism and the failure modes of generative AI, as well as the kind of correctness criteria and correctness guarantees we need when we're working with more traditional software models. Awesome. So what is Guardrails AI and how does it work? It's something akin to a safety layer around your LLM systems. So if you think about any traditional LLM application, how it typically functions is you have some application logic. And within that application logic, you would typically have, an LLM module where you have a prompt, where you do a lot of prompt engineering. You figure out what the best prompt that works for you, that gives you more success than other prompts. That prompt is sent to an LLM API. For example, OpenAI. You end up getting some raw output back, and that is kind of fed back into your application logic or maybe shown to the user, right? What we recommend as the more reliable framework to work with large language model applications is to combine this with a verification suite or verification logic, where there's independent correctness checks that encapsulate any criteria that is required for the usability of your application. So as an example, let's say you're building in a domain where privacy is really important for you and you can't leak any data. Your verification suite can have one check here, which essentially contains making sure that there's no PII that is either sent to the model and leaves your cloud, or that is generated by the model, right? Because there are a lot of data leaks contained within the prompt, within the outputs of these LLMs, and then you end up showing that PII out to your user. So that is one independent check that you can run on the system. If you're making, again, a customer-facing application, making sure that your output does not contain any profanity. Let's say you're also building a commercial application and you want to make sure that there are no competitors ever that are mentioned, right? So you're making a chatbot for placing orders with McDonald's. You want to make sure that somebody even asks, the chatbot, like, what's the best burger in town? They don't respond with Burger King. Like, that's a very key criteria, but that's not something that, OpenAI or ChatGPT will provide you. But this extends beyond just text. So for example, if you're generating code, making sure that that code is executable, not just generally, but like specifically in the environment and with the abstractions you work with, or if you're doing summarization, making sure that you can exactly cite and quote where that summary kind of came from as a way of building trust, right? And so the overall framework we recommend is that instead of sending this raw output directly back to the user, you first pass it through this verification suite where you can configure what your risk profiles are for each check in this verification suite. Only if you pass validation, given your policies, do you then send it back to the user or to your application and follow the path you would have followed in the chart on the left. If not, you can handle these policy failures independently, right? In the extreme, if you really care about correctness, you can use this novel property of LLMs, which is their ability to self-heal or correct themselves when you give them directions about why they were incorrect. And so you can re-prompt the large language model with like, okay, your previous response looked like this is why it's incorrect, try to correct yourself, and then more often than not, you'd end up getting responses that are much more reliable, much more correct, in production. So awesome. So this is the framework we propose. And then this is how Guardrails AI actually implements this under the hood. So I hope you can, I hope the text isn't too small, but broadly what you do is you initialize what we call guards. And guards are, these LLM level abstractions that allow you to encode what your correctness criteria is that you can specify from a number of these, input types, using Pydantic, using strings, or using, a new markup that we created, which is a dialect of XML, which we call Rail. So you do this at initialization, and then at runtime, what you end up doing is that any LLM API that is generated, if invalid, kind of goes through this loop, and only if it's valid do you end up returning to the output, and every single execution of the guard and of the checks that you ran on the guard and the corrective actions that you took when the checks failed, every single instance of that is logged to your log storage. So within this framework, what does Guardrails AI do for you, the open source framework that I mentioned before? So it's a fully open source library that, first of all, offers you a framework for creating custom validations. And then it orchestrates the execution of these validations in a very, very efficient, very low latency manner, performs verification for you, and if verification fails, it allows you to, correct yourself via reprompting. It is a library and a catalog of many, many commonly used validators and verification checks across a bunch of different use cases. And then finally, it's a specification language for communicating your requirements to the LLMs so that you end up getting responses that are primed to be more correct rather than if you didn't include that information. So a very common question, if you're familiar with like retrieval augmented generation systems, or if you're familiar with like fine tuning, is like, why can't I just prompt engineer my way out of this, or why can't I just use like a better model, right? Why can't I just fine tune on my own data? So if you're trying to control the LLM responses with prompts, like including retrieval augmented generation, which essentially just injects some context into your prompt about maybe your own custom data source, the issue remains that LLMs are stochastic at the end of the day. So even if you do the best prompt engineering in the world, the same inputs do not equal the same outputs as you keep running this consistently. The second is that prompts don't offer any guarantees. You can, do all the prompt engineering in the world. You can include like all of the instructions of, hey, this is how I want my output to look. Make sure it has this property and that property and this other property, etc. But there's no guarantee that the LLM is going to follow that instruction because at the end of the day, it's a next token generation system, right? The second is controlling your LLM application with just a straight up better model. Like, why can't I use just the latest and greatest model? Or why can't I fine tune on my data? TLDR, you should, right? Like, if you have access to better models, go for it. If you can't fine tune on your data, go for it. The issue remains that it's very expensive to train and fine tune models. Typically, you need really great data. This was my entire background, what I did for my big number of years just training models. And I got so frustrated by it that I joined a startup whose sole purpose was to kind of make it easier to do this. The second alternative, if you aren't training your own model, is that LLMs are hidden behind APIs, right? And then under the hood, you typically find that the model updates even when a new model version isn't released. So for example, as part of building Guardrails, a big chunk of my job is making sure that you get consistency. And then I start getting feedback from my users that, okay, this prompt isn't working for me anymore because even though OpenAI didn't release a new model version, they updated the model under the hood, right? So as a developer, you have no control over your actual model. Awesome. So we talked about the general framework for Guardrails. We talked about some example Guardrails. How do you actually implement these Guardrails under the hood, right? So I keep getting a lot of questions from users, which is that, is this basically just another LLM that is looking at the output and seeing if it's correct, right? Sometimes, yes. Sometimes you can use an LLM to verify and check whether this output that you got is correct. You typically do end up in the situation of, who will guard the guards? Like, how do you know if the verification LLM is working? But there's nothing that constrains you to use LLM self-verification. There's a lot of other paradigms that we offer based on the actual problem that you're working on. So as an example, let's say you're generating code, right? And you want to make sure that this code actually works for you and is correct. What you can do is ground this output that you generate in some sort of external system. So maybe this looks like I'm generating SQL queries and I want to make sure the SQL query actually works for my database. So what I'll do for you is hook up the LLM output to some some sandbox that mimics, what your actual database looks like, and then you can find if this query is correct, if you need to, if you're getting the right data, and if you aren't, you can, do this verification and self-checking. So text-to-SQL is actually a use case that we do well, and we found that this re-asking system in production actually leads to a huge lift in the amount of, usable SQL queries that you end up getting from the output. Another is rules-based heuristics. So you can essentially be like, if my output doesn't match this regex pattern that I want, you could reprompt it, correct it, etc. Traditional ML methods, like traditional small, low latency classifiers, or even more precise, deep learning classifiers that are not large language models, but smaller, medium-sized models that are very, very hyper-specific to your task, and for which you have you have confidence, ranges about how reliable are these verification checks. And then, of course, LLM self-reflection and self-evaluation. Awesome. So now let's think through how do we actually, if we were to actually build a system with Guardrails, how do you build, an internal-facing chatbot where you always want to generate correct responses? So you're a company, you're basically building a chatbot over the Help Center articles, and you want to make sure that your LLM output never hallucinates, it doesn't use any foul language, and you never mention any competitors. So first, a little sidebar. How do you prevent hallucinations, right? The question that's top of everyone's mind. So what we have in Guardrails are this paradigm that we call provenance guardrails, right? And the idea of provenance is every LLM utterance should have a source of truth. And so the idea is that you can break up what the LLM generates into smaller chunks and then try to cite where exactly this chunk came from. And if you're able to establish provenance, that's one way of interpreting that this output wasn't hallucinated. If there's no provenance, you can't establish what the citation or what the source of this was, then you can arguably infer that this output or this utterance was hallucinated. Actually implementing provenance guardrails, in the open source framework, we have a few different paradigms or a few different versions that do this. The first is via embedding similarity. So you can, just check for the similarity of individual LLM utterances with, smaller chunks of your source text. If there's enough similarity, okay, this came from that source. Very fast. doesn't work as well. So if you care more about speed, not as much about correctness, maybe this is the paradigm for you. Whoops. A classifier that is built using an NLI model, a natural language inference model. So essentially what you're doing is training a smaller, high precision classifier that allows you to say, given my premise, how likely is it that this utterance is correct, right? So of course this is also a deep learning model under the hood, but essentially you want to make sure that you're not using this really overpowered, really hard, really unruly model to solve what is at the end of the day a much smaller task, and so you end up getting a much lower latency, a much higher reliability model as the output. And the third, as always, is LLM self-reflection. Awesome. So we have our little sidebar about how do we prevent against hallucinations. If you were actually building this guardrail or this chatbot with these guardrails, how would you do this using the framework? I've added a small code snippet here where you can initialize the guard from a string. So you can essentially say that I want these 3 guardrails, which is provenance, making sure that all of my output is profanity free, and making sure there's no reference to peer institutions, right? So these are all like modular blocks that you can mix and match and combine and make sure that they're always running on any output that you get. And then finally, anytime you call your OpenAI function, which is some pseudocode that I've added there at the bottom, you can make sure that that guard is always running and making sure that none of these constraints are violated. Cool, so this should be familiar to us a little bit by now. What's different is the 3 checks that I have, as my examples. So instead of, all of these other example, checks that I included earlier, now in our guard, we have just these 3 checks that, correspond with the correctness criteria that we care about: provenance, profanity, and no peer institution mentions. And I'm going to run through this workflow of what happens when a customer question comes in, right? So let's say you're a mobile application. Somebody comes and asks your chatbot, how do I change my password on this application? There's a prompt that, again, you've done a lot of prompt engineering. Maybe you've done retrieval augmented generation, and you end up constructing a prompt that you send to your LLM. How do I change my password? From my retrieval augmented generation, you'll, add chunks to some articles in there. This is what your raw LLM output will look like, which is log into your account. There's user settings, at the top left corner of your application. Click change password, right? So this is a toy example, but this toy example is actually rooted in a real live failure of hallucination that I saw, which is that LLMs can't actually see, right? So they're just guesstimating where the settings button is. In your application, the settings button doesn't actually exist in this top right corner. So when you pass this, through your verification system, you'll find that there's no profanity, there's no peer institutions, but provenance fails, again, because you're hallucinating, where this top left corner settings button is, and it's not actually there. And so this is where Guardrails kicks in, right? Suppose you care enough about hallucinations that provenance triggers re-asking for you, where you essentially construct this re-asking prompt, and you say, hey, this statement was not present in the docs. Please take a look at these docs again, and then generate a more correct response for me. This time around, the LLM performs better. It says, generate settings by clicking on the menu. You pass this whole output through your verification suite again, and your verification passes, at which point you can safely share this output out to your application. So this is, an example of what Guardrails look like as you're actually working with them in prod. Very briefly, in the interest of time, I'm going to go very quickly over this. All of what we talked about was on a single LLM level. Typically, you'd have a bunch of these LLMs piped together. So let's say you have these 2 different one LLM chain which combines 2 different LLMs. One is a mapping chain, one is a reducing chain. When you're working with Guardrails, you'll typically make sure that you're injecting verification at the output of each LLM call, right? So you'll have different Guardrails configured with different policies, making sure that you don't have compounding errors as you run through the system. Very quickly, examples of guardrails for customer support. They span, all of these different axes around assurance and trust, compliance, brand safety, sensitive information, data privacy, etc. And some examples of what guardrails you might want to enforce. So making sure that no responses violate any laws, especially if you're in a compliance-heavy industry. Don't use any sarcastic or angry language. If you're doing something that's customer-facing, sensitive information, make sure any input-output is, only necessary information, responding within category boundaries, no leakage of sensitive data, etc. Some more examples of validations that you can run as you're building things in production. No asking private questions, no profanity, prompt injection, never expose prompt sources. And these can really be anything that you can encode into a verification check can become a guardrail. In summary, this is what we do. We're a framework that allows you to create custom validations. We're a catalog of many different validations, implemented that are ready to use. We orchestrate verification as you're building LLMs, and we're a specification language that compiles your requirements into your prompt and then sends it to the output. Whoops. To learn more, you can follow along. Guardrails-AI/guardrails is our GitHub repo. Our website is guardrailsai.com. You can follow me on Twitter or the Guardrails AI account on Twitter, where I talk about this constantly. And that QR code is for my LinkedIn, which you can use to follow along. Thank you so much, everyone.
We have some time for question. Okay, we have, the mic is coming. Thank you.
So, for verification rules, do you find you get better? For verification rules, do you find that you get better results for including some of that in the prompt up front, or only when you found a violation?
Yeah, that's a great question, honestly. So I think like one way to think about this is what I like using the trust but verify. So if you include some of those instructions, of like, for example, only use sources that are from the text, don't use any profanity, don't mention any of my peer institution or competitors. If you include that upfront in the prompt, you are priming the LLM to generate more correct responses than if you didn't, right? You'll end up seeing your success rate being higher. But once again, at the end of the day, you should like it's trust but verify. So you trust the LLM to do something, but you should always run this in verification. So after you give those instructions, you should ideally verify that everything aligns with your expectations. And so this is also kind of how Guardrails is created, where you can compile all of these rules, right, that will run actual programmatic checks on the outputs. But then you can make sure that one of the things that Guardrails does is all of those validators are converted into prompts that get inserted into your prompt, which we do for you programmatically, so that you're priming the LLM to be more correct than if you weren't. But yeah, great question.
Hello. Would you be able to extend this guardrail framework to other sort of machine learning model, for example, computer vision models or time series?
Yeah, another great question. I get asked this a lot. Yes and no. I think what you will be able to extend is this. I think the philosophical idea of what you're doing on guardrailing remains consistent, right? Which is that on any output, including computer vision outputs, etc., you have some idea of what correctness may mean for you. So many different images can look correct, right? But you care about not pixel by pixel comparisons, but actually looking into is there, if I want to generate an image of a car, does it have 4 wheels? Does it look this color, etc., right? So the idea is that you break up what correctness means to you into these small verifiable checks, but how you actually execute that verification framework will look very different. So the process of looking at an image extracting semantic properties from it, like based on verification, is going to be very, very different for like vision compared to text, compared to like time series. But the idea is still the same, which is that you extract these semantic properties and then check, if each separate like semantic property is like respected or verified. Yeah, hope that answers your question. Good. I think your audio was a little bit lower. I think your question was like, what does the open source framework offer you? Like, is it a hosted solution or is it, in your application?
Yeah, what's doing the guard inference?
I see. Gotcha. Yeah, I think, good question. So there's two different things. All of the talk that I gave today was for an open source framework. So how it works, it is a pip installable library if you're working with Python. And so it will be completely, wherever your code lives. So no request, like no need to either host a client or make a request to us. Separately from the open source solution, which I haven't talked about today, is that we at Guardrails AI are building a platform to look at this, from a much more rigorous standpoint. Like if you're in an industry that really cares about like safety, assurance, compliance, etc. But that's a slightly separate product that I haven't really talked about. Yeah.
If the guard fails, the corrective message gets into the history of the chat. If there are multiple such failures, is a chain, like will it kind of abruptly ends the conversation if it happens multiple times? Right?
Yeah. So that is a policy that you can configure. You can either set like budgets in terms of, like how many times you want to re-ask. One of the things that I didn't cover in the talk for the interest of time is that re-asking is one of the policies. You can also look to, okay, if this doesn't work, I'll fall back to some other framework where I either rope in a human or I use some other programmatic code, or maybe I just, do nothing but just log it into my logs. So all of those are policies that you can set on an individual like guardrail level. Specifically for re-asking, you can configure like when you want it to be triggered, how many times you want it to happen, how you want it to change like across different calls, etc. So all of that is configurable. Yeah.
I wanted to ask what the latency hit for all that validation is, or is that like on the customer, like based on my infrastructure?
Yeah. Really great question. So there is a latency hit. Like in general, there's no free lunch. You're fundamentally, like you are running some computation, and so, there will be some cost of doing that. What we do as a framework is try to like parallelize this and like stagger it so that the latency overall with like using our framework is much lower than if you weren't. But it also depends on the actual specific checks that you run. So typically I talked about different under the hood, like what each guardrail looks like. If you have LLM based guardrails, one issue that we see a lot is like not only are they a little bit less reliable, but they're also like they add a lot of latency, right? Because every time you run the guardrail, you have to make this request. For rule based systems, etc., they tend to be much faster, and there's this whole spectrum which you can configure based on how much you care about correctness, how sensitive you are to latency, and then how sensitive you are to cost. And there's typically this trade off between like those three properties. Yeah.
This might be a basic naive question, but you mentioned that the LLMs are good at self-healing. Is there a situation where a policy is no longer needed and it's pretty much correct, and a way to retire policies, or is it not something that you see?
Can you give me an example of that?
So if there is a policy or a check that you've put in place for, say, provenance or whatever, and it has been correct in terms of passing that. Is there some, I guess, dashboarding or some level of surfacing the information such that a policy could be retired?
If I understand your question correctly, is it that how do you understand, like, if you deploy a system, if a policy stops being required, but you're still running it? Is that the question? Yeah, I think that's an interesting one. I think the answer to your problem, I hope it's a good answer, is that the framework that we have is typically you have an application that's ready to ship into production, and then you as a developer know what are the policies for you, right? So you do that initialization or that configuration of policies like upfront, and then like once you have your application deployed, then you're running these guardrails like just consistently always. So I think that's kind of how we work, which is that you set this up front and then you kind of keep running this. If a policy stops being relevant, like your workflow would typically be to go back to that to the guard configuration, remove that like provenance check as an example, and then just update like your code in production to like not execute that. Yeah. Hope that answers the question. Yeah.
So we are taking a little break. Session will start again at 3:45. Thank you so much, everyone. If you have more questions, feel free to contact Shreya directly. And thank you so much, Shreya, for the nice talk. Thank you.